right, build show. Steve Basic Architect. We are back out at our multi-gen project. Now, hopefully you've been following along. We got the foundation in, framing, roofing, roof frame up, trusses were flying in. Hopefully you enjoyed those videos. But now we're on to kind of a new phase of the project where we're putting everything inside the frame behind me. Today we're gonna go in there, we're gonna catch up with Mark from Mac Electric. They've been wiring the house, and we're gonna go through and see the do's and don'ts of a high performance home when it comes to the electrician. So let's get inside, we'll catch up with Mark.
Multi-generational home on a budget. A Build original series brought to you by Zip System Building Enclosures, Fantech, New Wool, Bosch Home Comfort.
All right, so we're catching up with Mark, owner of Mac Electric, right?
Yes.
All right, tell us a little bit about Mac Electric.
We're located in Dartmouth, Massachusetts. We've been in business, September will make 10 years. So about 20 employees, and we do a lot of residential, commercial, industrial, electrical work.
Okay, do you have partners? You said we.
No, I'm just...
we as all the employees.
Yeah, yep.
I gotcha. 20 employees, God bless you, man. That's a lot of potential babysitting.
Yeah, the guys are great though, so it makes it easy.
They're good. And I know you work with local trade groups, because we were talking earlier about one of the gentlemen, and he's a co-op.
Yes, yeah, we work with a local vocational school. We take a couple co-op kids on a year, and hopefully we train them and they become full-time employees once they graduate.
Gotcha. Now, we're on the second floor, first floor of the upstairs two-floor apartment. Below us is the ADU. Remember, it's a multi-gen house. Now, the concept here is that you always wire from the top down.
Yes.
Right? But our mechanical room is in the basement. So what I'm going to suggest is, why don't we head down to the basement? We'll do a little quick talk about the panel. I know you do some things a little different from what I've usually seen. And then we can head on upstairs, because that is pretty much well done or wired, right?
Absolutely, yep.
And then we can close it out up there.
All right, that sounds great.
Let's head on downstairs.
All right, thank you.
All right, so we're going to squeeze into the mechanical room here, catch up with Mark. What's up, buddy?
How are you?
All right, so electrical panel. I know there's all kinds of rules about clearances, stuff like that. So let's talk a little bit about the placement of the panel. I notice you have conduits coming in down below, which is a little out of the ordinary for me. A lot of times I see them, they come in off the top, come down into the panel. So let's hear it.
Correct, yeah, so we come in through the foundation. It takes a little bit more time up front to do that. We come in, it makes two trips for us, but in the end it looks a lot better. It cleans up all the conduits from the outside coming in. You no longer see those conduits coming up through LBs. Your LBs are now on the inside.
An LB is?
It's a simple, it's almost like a junction box where you're gonna run the wires through the LB. Makes it a pull point. Okay. So it makes it a lot cleaner on the finish, better quality installation in the end. We also, seal the pipes once it goes into the panels as well with an appropriate sealant. Once we do that, it makes a really nice look in the end.
Gotcha. And I noticed, right away, we have specific clearances we have to have in front of the panel, right?
Yes, correct. Yep.
And I noticed there's not one plumbing pipe above it. Everything comes to this side of the panel and stays on this side of the panel.
Correct. Yep. We did a lot of mapping out on the front end of this because it's such a tight mechanical room, and the space is minimal. So we do all our planning where we have our 3 feet of clearance in front of the panels. Nothing going over the panels. We kind of dedicate this whole space here just for our area.
Right. Let's talk a little bit about Massachusetts electrical rules. Now, I believe the panel here has to be sized so that the whole house can be electric if it isn't.
Correct. Yep, that's new code. Essentially, you got to size the service appropriately to be able to go all electric if the owner decides he wants to.
Right. Now, you don't have to put in an electric stove, but regardless, the electrical panel has to be serviceable to a full electric house.
Correct. Full electric house. Yep.
Got it. Got it. So what size panel? What are we putting in here?
We have a 200 amp panel going in here, 42 circuits, minimal. This typical house has a lot of different circuits, so we're actually going to be adding a larger panel, which is going to be a 60 circuit panel in here, which is going to accommodate a little bit more in the long run.
And how many amp service are we putting?
It's going to be a 200 amp.
200 amp service in here. All right. Now, one of the other interesting things beyond bringing that stuff in low, a lot of times I see electricians, the first thing they put up is the panel. And I notice here, we have a lot of wires just hanging.
Yes, that is correct. We don't put any panels up and we don't cut any panels in until we're fully 100% have every wire pulled in the whole house. Reason being, we don't like doing things twice, and we like pride ourselves in putting a nice neat panel. So once all the wires are pulled down here, we cut the whole panel in.
And you can sort through the wires, you can accommodate the sequence or however you want to place it, create artwork, and be done once.
That is correct. And
Once
we also make sure we do that when we're roughing in a house. A lot of guys would leave the wires hanging, maybe cut them into the panel, just let them sit in the panel. On the rough stage, we do it a little bit different. Once we're on the rough stage, we put all the breakers in, we land them on all the breakers, and on the finish, it makes it that much quicker as well.
Right. Now, one of the things I heard you talk when we were talking earlier today, you guys do top-down construction.
Correct.
So
yes.
we're 3 stories here because we have a walkout basement, we have our first and second floor primary occupancy. The in-law suite is on the basement level. So why don't we head upstairs where we're fully wired, and we could talk about the somewhat differences that you had to encounter with the air barrier that we chose and we designed that you had to work around.
Absolutely.
Let's head on upstairs.
All right.
All right. So I thought, Mark, before we headed upstairs, let's just take a quick stop again here on the second floor because I see your guys are pulling wires. But one of the things I'm always intrigued about is, as an architect, I plan the house, we do electrical plans, but as an electrician, I'm sure you have a format of how are we going to attack this house?
Yeah.
Right? How do we start? What's the first wire you pull? Where's the first hole you drill? Tell us a little bit about your plan.
The first thing we do all our layout first. We usually typically will run through with the homeowner or the contractor, run through the entire layout, and then we'll start from top down. We start laying out all our boxes, nailing our boxes up. We'll start drilling all our holes after that, and then we'll do the ceilings first and move to the power. So basically, again, with the top down, we always start ceiling, laying out all our boxes. Every box usually gets mounted before we start pulling any wires.
Right, so that way there you can see, okay, if I have a switch box here, I have recessed can up there, I have to connect that to here, and then you can strategize basically how those wires go.
Yeah, and by mounting everything first too, you're not always doing things twice. You're not rerunning wires or moving wires if you have to put a recessed light in a certain spot or an exhaust fan in a certain spot. You don't want to have to move your wires or do anything twice, so we try to get ahead of it, laying out everything first.
Right. Now, I see the letters here, HR. I know what that stands for, and we're not talking baseball.
No. We do call it a home run. That's usually the dedicated circuit that's coming from here all the way down to your panel,
right.
Which we, again, once we have all the wires run, then we mount our panel and cut it in our panel.
Got it. And this home run, like you said, it comes from the panel, it comes to here. That'll plug into a box. It might feed 1 or 2 boxes, but it doesn't feed 20 boxes.
Correct, no. Nope, it'll be, these for instance in here are your circuits for your kitchen. These 2 are dedicated circuits for your countertop receptacles.
Okay.
So for instance on these 2, you'll only have the dedicated circuits for this receptacle in itself.
Right, and this is a 12-2.
12-2, yes.
Got it, and you can see, planning, like anything, making sure that you have it labeled. I'm sure you've walked through a project where you have a new guy and you walk through and you don't see it, and it's like, okay, where does this go to?
Correct, yeah.
Right.
We are big on labels. We try to label everything.
It takes a lot of time, and same in architecture. It's like if you don't understand what that is, 2 weeks later when you come back, you're not going to remember.
No.
You're not going to remember what all these wires go to. So the proper planning, having a system in place where your guys understand that system, it's imperative to the success of the building.
Correct, yeah. Labeling is everything.
All right, let's head upstairs where we get a lot of wiring. It's completed. We can talk about setting up some boxes and a few other aspects of what you guys do. All right, Mark. So we're up here on the second floor, which is actually the 3rd floor of the house. It's the second floor of the upstairs unit. And like we said, when we were in the basement mechanical room, you work from the top down.
Correct.
Which I think is a really smart way to do it. Get all these wires down through the house, and then the second floor obviously down, and then the bottom floor would be the last one to be serviced. But up here we have some challenges with our air barrier. But I thought before we jump into all of those details, let's back that truck up. Let's go right to square one and talk a little bit about what kind of wires we use, why we use them, and sizes. So Mark was really good. He went and caught a bunch of samples of the different wires that we're using in the house. Let's start with one that we probably don't use a lot, but it's important, right? The big heavy one.
Yep, this is a 10 gauge wire, good for 30 amps in a house, and typically we're going to use it for dryers, some AC condensers, a lot of things that draw more amperage. We're going to use number 10 for it, and again, it's 30 amps. It's good up to.
Gotcha. And for those of you that don't know, the lower the number in gauge, the bigger the wire.
Correct. Yes.
So as I increase the number, the smaller the wire gets. So
Correct.
10 gauge. If we go down to the 12 wire, which I believe is this one.
Correct. That is the 12. This 12 is going to be most commonly used in bathrooms, kitchens, dining rooms, and that's going to be a little bit smaller gauge than a 10, but it's going to be one of your most commonly used wires in a residential home.
Right. It's not quite a big appliance, but you can imagine the outlet that you're plugging the 12 gauge wire into. It services things like a blow dryer or a toaster in
Correct.
the kitchen, something like that. It's not servicing a desk lamp.
No.
In a kid's bedroom, or the Game Boy or whatever in there, or Xbox. And that 12 wire is what we would call a 12-2.
12-2, yes. They also make a 12-3 if
Okay.
you need it. Some bath fans use 12-3. If they have a heating element in there, they might use that. But it's not as common as the 12-2.
Right, and the reason, my understanding, the reason for the 12-3 is it has a wire that obviously we can switch from two positions.
Not necessarily two positions, but it allows you to add another switch leg, another wire to turn maybe just a heater on in a fan. So basically, if you're in a bathroom like we are, you'd have one switch that turns a fan on, one switch that turns the heat on the fan on, and
Gotcha.
then the other turns the light on. So it just allows you to do more with the wire.
All right, and then the ground is servicing both of those applications.
Correct, yeah.
Right.
The ground you're going to use throughout the entire home as well.
Gotcha. And then the two wires that I hold, these are probably the most common in the house, a 14-2 and a 14-3.
Correct. Those are the most common used wires. I'd say the 14-2 we use most out of any of them. That's going to be in your bedrooms, hallways, any common areas that don't have appliances in them. That's going to be used in those locations.
So this is basically the workhorse of the electrical system in the
Correct.
house, right?
That's
Most of the house is running through that.
Yep, and all your lighting runs through 14 as well.
All right. So thanks for that education on the wires. Let's talk a little bit about what you guys do, because, like all the trades, they're all masters of their environment, right? Now, you could say, hey, how hard is it to, wire a house, make up a box? But there's a whole lot of talent that goes into making up a box.
Yeah.
There's a whole lot of planning that goes behind it. If you don't mind, I'm just gonna pull one of these out, right? So obviously we have a bunch of things connected there, but I see you leave a little sleeve on here, and it says recess, so obviously that's probably a light switch that goes to the recess lighting.
Correct, yep.
Right, so you leave that on there, make up the box. I also notice, I pulled it out, but all this stuff is tucked in there nice and neat, because you guys are deathly afraid of the drywall guys.
We are, yes, we
Right,
are.
they like to go in there with their little roto tool and turn this into spaghetti
Correct.
if it's not fully tucked in there.
And that's why we also roll them up like this. And if they happen to, we hope they just nick the ends and not so much back on the side of the wire. So that's the reason why we roll them up.
Right, so basically you don't need all of this wire. It could be cut back here.
Yep.
You do that as a precautionary measure if I have to cut this wire back.
Correct. We typically leave a little bit more slack. We'd have rather have a little bit much than not enough. So it's 6 inches code that you need in the box coming out. So we try to leave it the 6 inches and then some. A rule of thumb is, we usually put our hands here, thumbs out, and then we would cut. So that's typically how we would make up boxes, and we leave the labels on just to make it so much easier. If a lot of customers can, be a little bit picky and say, hey, I want my recessed light on first and I want my fan on second. By leaving these tags, we know exactly what they're going to control when we go to put the switch in on the finish.
Gotcha. And when we walk through with Brett, owner and client, he stipulated, hey, I want the lights, I want the fan, and I want this.
Correct.
So, when it's a 3-gang box like that, you have the choice of where do I want to put it. And the most common feature you typically put
Correct.
closest to the door.
Yep,
right?
we always try to put the most common one used to the door and then go out from there. We always try to put the fans last if we can. This way someone's not always turning the fan on and they don't hear it come on because they're all so quiet nowadays.
Gotcha. And, excuse me, coming through here, I see, okay, we have a block here. I know why that's there, but, a lot of you might not, right? That block gets pumped out because?
The molding goes on the doors and we don't like to cut plates.
Right.
So we always try to build it out a little bit more to avoid cutting any plates, and it looks a little bit cleaner. And in the end, again, it's the quality that we strive on to make it look nice.
Right. And now this wire is a little different, right? And it's a single that has a bunch of little wires inside. It looks like, I don't know, what's in there, 4 or 5 wires?
Yeah, this is an 18.5.
Okay.
Usually a thermostat wire.
Okay.
The thermostat wire is used to control air handlers, any heating systems. This one is going to control your heated radiant flooring. So that's kind of why one's tucked in like that.
And speaking of heated radiant flooring, I noticed we have another box here. And, one of the things that I don't think people appreciate enough, you can see things get nice and level here, right? Now, it's one thing when you're in the framing stage, but understand, at some point, we're going to put drywall on here. It's going to be a monolithic wall, and all you're going to see are these 3 boxes. So we want to make sure that we have proper alignment. Things are nice and neatly laid out. But this one here has an electrical wire, 3 there, or 2 wire. And then we have this blue tube that goes down to pretty much just the floor and hangs out. Let's talk a little bit about this box.
Yeah, this is going to be your line voltage for the radiant flooring. This typical floor heat requires the line voltage to be separate from the low voltage. This is going to be a line voltage. What's going to end up happening on the finish when the tile guy comes through and puts a tile in, he's going to push a wire right up through that tube into this box, and then that allows us on the finish to come in and put that thermostat in and have a finished product. It just makes it a little bit easier. We call it Smurf tube. It makes it a little bit easier on the finish. We're not snaking anything in.
Okay. I mean, it's basically a flexible conduit.
Correct. Yep.
That's basically in the wall there. And then that's going to feed. And this one here, we have a radiant
Floor heat.
electric mat in the bathroom here. So let's talk a little bit more about wiring. I mean, typically we use these U-shaped nails. They have the little plastic protector there. And I notice, you guys are very diligent about folding it around. Are there any rules of thumb that, if you were teaching me my first day on the job and you said, hey Steve, pull these wires and nail them, 4 inches from the box, do you have your rules?
Yeah, we typically always try to keep it nice and neat and clean. If you look at the insulated staples here that we're using, we always try to stack them to keep them a little bit closer. This way the sheetrock screws don't go through the sides of the wires,
right.
So we keep them as tight as we can to the inside. Here we have 2 stapled enclosed, but if you're going to go and staple into a box, again, we use that same rule of measurement. Anything with a thumb, you kind of want to staple in.
Okay.
Again, it's not a code thing, and we go a little bit above and beyond code, but we like it to look nice and neat and clean on the end. So we always say within a finger, hand's length, like this, we're going to put a staple. And that's going to keep you covered to be within code.
Got it. Well, all right. So since we're done with the basic stuff, pun intended, right? And we have that all figured out. Let's talk about the things that maybe threw a little curveball to you. Now, for those watching, this is the first time you've worked with Green Logic Builders.
Yes, it is.
Right. Green Logic Builders does a lot of what I would term passive house inspired. I've worked with them on projects before. We get our air tightness numbers down below passive house in a 4.4, 0.5 range pretty easily. Hopefully we're going to do even better on this one. When we did the roof framing, remember how we talked about putting in that Sigma vest, and then we talked about putting in the MyRex as our air barrier. So you can see above me, we have a membrane here. It's taped with the Reson tape, and then we have 2x furring down below. Now that 2x furring was purposely for you.
Yes, correct. Yep, that's how we run our wires back and forth in the ceiling without penetrating the membrane, which makes it a little bit more difficult. It was new for us as well. We haven't done this in the past, so it was a learning curve where, you know, over here, for instance, if you're drilling holes through, usually we can go pretty quickly and drill holes through every joist, but here you have to be a little bit more cautious, slowly drill your holes through so you're not puncturing the membrane above.
Right. So you have to exercise a little more care.
Yes.
And I know some of you sit there and say, oh, wow, I mean, that's going to be a lot more work. But, you know, I look at it as an electrician with a little more conscious effort is probably a good thing, yes, rather than having a guy and turning them loose and say, hey, go drill the holes,
yes,
you know, for the second floor. And they're just, I've been on projects where you turn the electrician loose and, man, they'll have one plate, they'll have 12 holes there, and then 2 wires are being fished out.
Correct.
You know, so they just like to go through. Now, technology certainly helps us in this detail, right? I mean, if we were using the hi-hats of old, we wouldn't be able to do this.
No, no.
Right? But the LED recess that we're using here, little hockey puck type lights, we could just put that strap in. It's all wired. I see that you have it taped off there, but you basically, after the drywallers are done, you reach in and grab that wire.
Correct. We reach in and grab the wire. We tape them off just to keep it as close as we can, where we don't want to puncture the air barrier later. We have those taped off temporarily until the sheetrock goes up, so it makes it a little bit easier for us on the finish to go up there, grab the wire, and put the wafer light in.
Right. So in this whole house, the floor is probably about 1,000 square feet. I'm guessing we might have 2 or 3 penetrations that go into the attic.
Yeah,
an attic light, maybe,
Yeah,
that we have to tape and seal. So it probably changed your mindset a little, that you didn't have that luxury of that space to just go up, staple it to the trusses.
Yeah, it was definitely a little bit different learning curve. Took a little bit longer, but you know, in the end, it's a quality install.
Yeah, and I'm guessing if this was your house, you'd probably want it done this way.
Yes, 100%,
right?
Where it's nice and tight.
A lot of guys, you know, and I found out early on, been doing, you know, high performance housing and stuff for a long time. After I have a conversation with builders, usually I'm designing and we're doing their house.
Yeah.
Because you guys are out here every day. You know what a good job looks like. You know what a hack job looks like. Correct. Right? You know a good way to design a house. You know when people don't care about what they're building. And so when Brett comes here with, and I would say he's excruciating in care.
Yes,
like
yes.
If you punctured a little hole, it'd be like, oh my God, we got a hole. And I know, Brett, you're watching this, but that's all right. But he's you know, perfection for him. And so for you to come on board and do this, you know, I credit, you know, your openness to do this. I get a lot of clients that say, well, you know, my builder, he's never built a passive house. He's never done this, never done that. You really don't have to be someone that has experience to this. You just need an open mind, have a conversation, do some proper planning. I'm sure you had your guys up here and told them nothing goes through the membrane.
Yes. Yep. We had several conversations, and just to be extra cautious when you're drilling holes.
When you're drilling holes. And it's a job very, very well done. One of the better wiring jobs I've seen. You guys did a beautiful job. And, you know, the beauty of it is that it's going to perform as good as it looks. All of the wiring in this house is inside of our air barrier. So the only penetrations are the services that are being linked to the outside. You know, an outlet and a light switch in the attic, a couple electrical outlets that service the yard. But short of that, we've wired everything kind of like inside the sub.
Yes. Yep. Absolutely.
All right. Well, there you have it. It was great meeting you. It was great talking electrical with you. I won't brag, I'm not bragging, but years ago, I did spend about 6 months as an electrician. Realized maybe it wasn't quite for me, but that's all right. I have a lot of electrician friends, and you know, you're doing a beautiful job out here. And again, I can't commend you enough for being one of the subs that just says, hey, whatever you want, That's what we'll do. If that's your rule, then that becomes our rule.
Yes.
And you get a lot of electricians, they roll their eyes like, oh my God, here we go again. And it's really hard to work with that. It's the same for you. If you went to the counter in the supply house and said, hey, I need to replace this or return this, and the guy rolls his eyes versus the guy that says, hey, no problem, takes it and goes and gets what you want.
Yeah, you're just doing what the customer's
Right.
requesting.
It's just, we need to learn to play nice and do your job.
Absolutely. That's all we did here.
All right.
All right.
Well, thanks for that, buddy.
Appreciate it. Thank you.
All right. We got Wayne Foston, plumbing and heating, right?
Yes.
All right. Tell me a little bit about your business. It's your company.
Yes, my company, we started in 2016. Service the South Coast. We do plumbing, heating, air conditioning, gas piping.
Okay.
Did a little plumbing work on this project here. It was an interesting one, so.
How many employees?
8.
8 employees.
Yep.
All plumbers, or is it?
A variety, a mixture of HVAC contractors and plumbers.
Okay.
So.
Okay. So I thought, we'd start with some of the basics here. When I look at a house and I think plumbing, I think, okay, there's pretty much 3 different pipes in a house, right? And you feel free to correct me if I'm wrong. There's the pipe that gets rid of stuff, the
Yep.
drain waste vent pipe.
Correct.
And then there's 2 supply pipes, in this case, red and blue, cold water, hot water.
Yep, and in some instances you have gas piping as well, which would be black iron or like that.
Or something like that. In this house here, being all electric,
No gas in this house.
no gas in this house.
Correct.
Right? So it's either a wire or these 3 pipes.
That's it.
So the piping here, it's a plastic tubing.
Correct.
I didn't see much copper in here.
Nope.
Probably don't do a whole lot of copper anymore.
Typically, we just do copper now, like where shower valves are, just to strengthen the valves. That way they're not flimsy in the wall.
Gotcha.
Or, some of our sink stub outs would be done in copper too. That way the shutoff valves, are rigid,
Yep.
stuff like that. But yes, most of the piping that is inside the home now is all the plastic PEX piping. This particular piping is made by Watts. And the fittings here are the cinch type, which the stainless steel cinch rings, which we have a tool that basically crimps those and to the right pressure and locks them in, creates the seal.
Yeah, and those aren't leaking.
No, nope.
Not
So
leaking
we
at all.
put everything on air test, pump the house up to 120 PSI, which is basically double the working pressure.
Now that's the setup you have behind you here, right?
Yeah, this is a typical setup we'll put on a rough where we pump air into that and test all the lines to make sure they're good for the finish.
Okay, and you said you pump 120 PSI.
Correct.
How long do you test it for?
Usually we test it for a couple hours and
Okay.
then you're all set.
You're all set. Now, in talking with you, Massachusetts has some new things about their waistlines.
Yeah,
Right.
so a new code that is interesting this year is Massachusetts wants a tinted primer on all their joints to basically, show that the joints were solvently glued correctly, that people aren't just putting the glue on, they're also cleaning them. Now they have tinted purple primer, which is, the typical stuff that's been around forever. That stuff does tend to make a mess. Yes, you can do it neatly, but it adds a lot of time and effort to gluing the joints, making sure that you don't have purple primer everywhere. But a new product that just came out, I think about a year ago, it's made by Hercules. It's called Unpurple Primer.
Unpurple.
Unpurple. So basically, the joints still look like they're clear primer and glue, but when you take a UV light to them and shine them, you can see that
There's magic.
exactly. You can see that the tinted primer was applied, and it kind of hides it in case there's any overspill, like you see here and stuff, which
Right.
typically you wouldn't want to see on an install. It just keeps it nice and clean.
Now, does the plumbing inspector come around with a flashlight?
Yep,
And
that's
typically-
new code now. So he'll require us, the plumbers, to have the flashlight on site if we decide to use this, because you can still use just a standard tinted primer. You don't have to do the UV kind, but we elected to use this that way. It still looks clean and neat, and we don't have to waste a lot of time and effort trying to make those purple lines nice and neat.
I got you.
But we just have to provide the UV light for the inspector, and it's perfectly legal in Massachusetts.
Gotcha. Now, I know in planning a house, like the electrician and the mechanical guy, you have to plan for, hey, certain pipes are doing certain duties. Certain pipes have to be certain sizes.
Correct.
Right? So we have a drain from a sink, we have a drain from a shower, and a drain from a toilet. My guess is they're probably not the same size.
Correct. Typically, drains for a sink are usually 1.5 PVC. Standard drain size for a toilet would be 3-inch. And shower drains are typically 2-inch, but another code change allows you to do shower drains now 1.5 inches, providing you only have one shower head being used in the shower. If you have multiple shower heads, you have to stick with the 2-inch drain.
Gotcha. Now, and I notice behind me here, in strategizing for that house, we have a bunch of the pipes coming down. I'm assuming these are drain lines from the 2 floors above us.
That's correct.
And
so
they're coming into
those are servicing fixtures from the floors above. This is a utility closet / pantry you're in. So we got the clean outs from the drains upstairs in an accessible spot where they can be cleaned or accessed in case any of the drains become blocked in the future. They can unclear the blockage from those clean outs.
Right, when you talk about clean outs, basically it's these little caps here. You can unscrew those, pop them out. You can snake the line either down or you can snake the line up.
Correct. You want to try to place those in a spot where you can snake in both directions.
Gotcha.
Yep.
Gotcha. And I can see this is probably something coming from a toilet, and these are probably coming from sinks or showers.
Correct.
Just given their
Sizes.
size there. Now, this all comes down, it goes down into our mechanical room. We're on the lowest level of 3 here, and notice we have some drains that go down. We have a toilet there, but these drains behind Wayne, those go down into the floor. So those are basically below our septic system, which is outside the wall. So why don't we head into the mechanical room and we'll figure out how we elevate that and solve that problem.
Sounds good.
All right, so you can see that drain pipe, working with all of the trades here, notice that our stud wall is on the flat on this wall. And the reason for that is so that we can get this large pipe to run down, which is one of the main sewer lines in the house. You can see it's hangered there. And also very important, notice we have these protection covers that are nailed into the stud. So when the drywaller comes and tries to put a screw there, the screw obviously doesn't go, and what that does is protects the pipe behind it. So let's follow the pipe. And so we're in here, Wayne. All of these pipes come down here. These are, I'm assuming, vent pipes.
Yeah, so that's
out of the system.
That's a combination of the discharge for the underground plumbing below the slab here, and that's the vent that vents the chamber of the sewage ejector pump. So if you look over here, this is our main drain coming into the building, and as you can see, it's 4 feet up elevated here due to the height of our septic outside. So the problem and the challenge was all the plumbing down here in the basement level. We needed to put a sewage ejector pump in order to pump the sewage up to our main drain level here.
Gotcha.
So actually below the floor here, you can see that we installed the ejector pump.
And that was planned at the pre-slab phase.
Correct.
You came and did all the underground plumbing.
Correct. Before the slab was poured, we did the underground plumbing, encased all the pipes in sand, got it inspected. They poured their floor over. And then when we came back to the project for the roof, we basically piped in the discharge that comes off the tank here and the vent that vents the chamber down below.
Got it. And I can tell by the way this is plumbed, obviously this is the vent.
Correct.
And this is the discharge. It basically comes up and over and in. Now it's interesting that it doesn't come in and just go into the pipe, that it does this loop. Is there something special that has to happen here?
No, I mean, technically we could come in on the side. We were just kind of a little tight here with our fittings and tie-ins. We didn't really have room for a Y back here, and we didn't want to block this clean out. So we just kind of came up and over and down and placed it back here. Also note like the shutoff or service valves here. So if this pump ever failed or needed to be serviced or cleaned out, we would shut those valves to prevent any sewerage or backup coming back down when we disconnect the pipes. That way we can service the unit.
And these are inline on, right? Inline on.
Yes, and then against the pipe off.
Against the pipe is off.
Yep.
All right. Well, so that discharge is in. This is the main drain taking care of everything upstairs. That
Correct.
goes out to the septic.
So everything from the above floors is all gravity drained. The only thing that's on the pump is everything down here at the ground level.
At the ground level. So why don't we jump outside and see where that pipe takes us?
Sounds good.
All right, Wayne. So we're upstairs. We're in basically the entry hall, mudroom. We have the mudroom closet. We're going to have a little bench there, front door here. And we have this funky copper thing in the wall system. And I'm guessing that's not some kind of radiant heating system for this space.
No, Steve. So what this is it's a product made by Thermodrain.
Okay.
And yeah, so we're standing in the entry here, which is below the master bathroom upstairs. So right above us is the master shower.
Got it.
And what this drain does is when you're taking a hot shower upstairs, all that wastewater coming down our 3-inch stack here for our shower is going to run through this pipe. And then what we have here is our cold water feed that supplies our water tank, hot water tank for the house. Basically goes through this coil, and the water gets preheated by the wastewater from the shower while it's on its way to the water heater.
Right. So we have basically a pipe inside that coil.
Correct.
Right. When water goes down the drain, it's very important that you understand water doesn't fall down the middle of the drain. Water catches the sides and basically creates a film as it drains down the pipe. That film, as it drains down the pipe, and like Wayne said, we're directly below the shower. So I don't know, what shower temperature water? What's the temperature
Usually
in the shower?
about 115, 120.
Okay. So 100 plus degrees, water comes down, creates a film on that inner pipe, and then the outer pipe wraps around that pipe and basically acts as a heat exchange. Right, so we have, I mean, by the time it gets here, maybe it's 90 degrees.
Right.
And the cold water coming in, I'm guessing it's probably 55-ish.
Around there, yeah.
Plus or minus.
Depending on the time of the year.
So it's a 40-degree delta. But before we let that water go down into the drain and off into the septic system, we're trying to strip off as much heat as we possibly can and basically put it into that water supply that's going into the water heater, so that maybe that water going in isn't 55 degrees, maybe it's 62, 65 degrees going into the water heater, so the water heater has to do a little less work.
Correct, and save energy there
And
as well.
save energy. So there you have it. Well, why don't we head on upstairs? We could take a look at what's happening up there. We could talk a little bit about showers. I know we got a pretty cool bathtub up there. So why don't we talk
let's
about
head up
that?
there.
Hey, Wayne, I know we're headed on upstairs, but before we go, I see this little box, got a valve. It's got cold water coming to it. I know what it is, but let's inform our viewers.
Yeah, all right. So basically what this is the cold water feed for our refrigerator that's going to be here. And what this box does is allows the valve to be recessed in the wall. This way, if we came through the floor with it and you try to push the fridge back, it might get tangled up or not allow you to push the fridge all the way back. By having the box recessed in the wall, it gives you all that clearance in order to push the fridge all the way back. And if you pull it out to clean it or service it, you have a shutoff valve right there to shut the water down.
Gotcha. And the line is so that the magic of making ice cubes or filling your glass with water from the fridge, that water obviously has to come from somewhere. And this
Correct.
is the supply.
That's correct.
That's the shut off. All right, let's head on upstairs. All right, so we're upstairs. We're in the owner's suite in their bathroom here. A lot of cool little things happening up here from a plumbing perspective. First thing, double vanity, pretty standard.
Correct.
In most houses, right? You can tell because we have two drains, two sets of hot and cold water. But one of the interesting things here, Wayne, is that the water pipes aren't in the exterior wall, but you're okay putting the drain in the exterior wall.
Yes, that's correct. So you don't want to put your water lines in an exterior wall due to freezing purposes. Water lines are always charged with water. They're always going to have water in them. And as we know, inside the wall is colder than the room's going to be.
Right.
Therefore, you risk the potential of them freezing. A drain, however, only has water in it when you're running a fixture or draining a sink or so as. So most of the time, those pipes that are going to be in the exterior wall here are empty.
Yeah, and if they are draining, chances are they're probably draining some kind of warm water that if you created a little ice film inside the pipe, it's going to take it away anyway.
Ideally, you want to try to keep everything out of the exterior wall, but in some instances where this double vanity is on the exterior wall, this is the solution that you have to go with, and then the best practice is to keep the water lines out of the exterior wall.
Gotcha, and I can see Brett being the general contractor in, his sense of perfection, he laid out the whole vanity on the floor here for you, so you guys know exactly where the sink is going to be.
Absolutely.
Long before it comes
foolproof
in.
for me.
So, and I noticed, like we talked about earlier, we got those protection plates on that wall there to protect that pipe.
Yep, from any nails or screws when they do the drywall.
Exactly. So over here we have, I call them garden tubs. I think you mentioned it as an island.
So it's a freestanding tub, but what's unique about this one is we have an island drain assembly.
Okay.
So basically, right now we're on the second floor. When we come back to do finish on this freestanding tub, we're going to have a nice tiled floor here. And usually we set the tub in on finish after the tile's done. Now the problem with that is you got to connect the drain after the fact. So usually if it's on a first floor and you have basement access, you can connect the drain at that point in time. But where we're on the second floor, we're going to have a finished ceiling below us. So what the island drain allows us to do is it's a special drain that's a gasket sealed drain. We put the drain assembly on the bottom of the tub and basically pick the tub up and drop it on the drain, and that gasket creates the seal, which makes it so that way we don't have to open up the ceiling downstairs to tie our drain in on the finish.
So it has this kind of male counterpart that just goes down into a female receptor.
Correct.
And
the gasket makes the seal
gasket makes the seal around there, and the water's moving away from that gasket anyway all the time, but that allows you to do this post all of the tile. And then you can see architecturally we have this nice big window here, garden tub, we got a nice little shelf here, we have some specialty tile going in there, so can't wait to see how that goes. All right, well, before we head out, Wayne, let's head into the shower. We'll take a little chat. Notice that we dropped down 2 inches. That's for our curbless shower here. And here I notice exactly what you talked about earlier. We have the plastic piping coming up the PEX, and then you switch to copper.
Yes, that's correct. So we took our plastic PEX there, converted over to copper, made sure these valves are nice and rigid. That way when you're grabbing on them, turning the dials for your mixing valve or diverter valve, everything's solid in the wall. We have no problems in the future.
Gotcha. And then the components that we're looking at here, the mixing valve.
Yep.
Which is basically taking the hot and cold water and that's setting your temperature.
Yep.
Right, mixing the two to form one. The diverter is either controlling water that goes up to the shower head there, or it's diverting over to here, and I'm assuming this is a handheld.
That's correct.
All right, so, that's all of the controls in here. Now, one of the things I noticed, we have, obviously, this is our vent pipe. Correct. It goes up and it breaches our air barrier. Now, I see somewhat of a black donut on the back side of the Myrex there. Let's talk a little bit about how your strategy with the air barrier is a little different in this house than in some houses.
Yeah, definitely. It's a little bit of a different challenge than typical houses. So what we have to do with all our penetrations on the air barrier is we actually have these rubber gaskets here, and all our penetrations have to get sealed, creating an airtight seal around them. That way we don't have any air loss in the house.
And so this is just basically a self-adhering gasket, right? If I peeled this off,
yep,
it's got an adhesive back here, right?
Exactly.
And this you just basically slide down and then make sure with a little bit of force that we're in full contact with our Sega Myrex there, and then it has a pretty flexible inner ring, which I'm sure they make these for all different size pipes.
Correct.
And you just slide that over, and that maintains our air barrier continuity up there.
Yeah, and you can sort of see one here. You can see half of the seal there up there as well.
Awesome. All right, well, from the shower, let's go see what else we can find. Hey Wayne, I noticed walking by here, we have our typical gray, I call them gray boxes.
Yeah, typical laundry box, yep. Recessed laundry box
there. So we have our hot and cold water, and then it has a drain in the middle, obviously, there. So we have the shutoffs. It's interesting. We put shutoffs there, and then a lot of times some plumbers will put them, on the back wall, and it's like you put a shutoff in one of the hardest places to shut off the water.
Right. You want to try to make them accessible in case of emergency. You can access them, kill the water at the appliance, and service it.
Yeah.
One other thing to notice about the shutoff valves here too is they have built-in hammer arresters on top of them.
Okay.
So basically a wash machine is a mechanical appliance, so it's an electronic valve that opens and closes shut. So that can create water hammer, which is basically turning the water on and off too quickly and creates a shock wave through the pipes and banging.
And that's the pinging you hear in a typical old house, ping.
Correct, and that's more so with the copper piping, rigid copper piping through houses. That is alleviated a little bit with the flex of the PEX piping now, but you still do get some of the bang, and those hammer arresters help eliminate that.
Gotcha. And I don't think people realize, but like one of the #1 leaks or top leaks in a house is the washing machine on an upper floor.
That's correct.
Right? I mean, the rubber hoses, I mean, when you're buying your washing machine, nobody's giving you the best hose with that washing machine.
Right.
The first thing you should do, I tell people, is get rid of that rubber hose, get a nice braided hose.
Yep, nice stainless steel braided hoses. They do make the flood safe ones too, which actually, if those blow off, they sense the pressure difference and the hoses themselves actually shut off.
Wow.
Which is nice.
That's very nice. And then I noticed we have this 1.5-inch pipe down by my feet here. And that is also in tune with what if we spring a leak up here.
That's correct. So what that's going to be for is a safety pan that we're going to install on the finish underneath the washer and dryer setup here. In case of a leak, it's in hopes that most of the water gets in the pan, fills the pan up, and then goes down that drain, which will then go downstairs and into our sump pump and fill that up and get pumped out from the house.
And get pumped up. Because I was going to ask, where does that go? Because you can't hook that drain really to the regular plumbing, because if it has a trap or something, it's going to dry out.
If you hook up to the regular plumbing, it gets a little bit more complex. You need to trap it out, and you'd also need a trap primer. Because it's going to be a drain that doesn't see water hardly ever, that trap seal would eventually dry out, so you would need to install a trap primer on that. So the best bet is to just get rid of it out of the sanitary system, and in this case, we put it in the sump pump pit.
Gotcha. But yeah, great idea. We're doing that a lot on projects lately, but in this one here, that foresight that you're talking about of dumping that into the sump pump so that it can communicate with the conditioned air in here, and you don't have to worry about sewer gas or anything like that communicating with it. So, all right, well, let's continue our trip. All right, Wayne, so we're outside. Now that pipe that we were talking about, it's probably a couple feet below us here, but it's coming out in this general area.
That's correct.
And it's feeding the septic tank. We know this is a septic tank because we have the 2 caps here.
Yep, split tank.
Split tank. The first tank is settling the solids.
Correct.
Right, out of the system. The water goes into the next chamber. The second cap there is to access the filter, I believe.
Yes, and they can actually pump the tank out from there as well.
They can pump the tank out from there. And then from there, it goes to the concrete box.
The distribution box.
Short for D-box is what we usually call it, but it's the distribution box. It's basically one large pipe in, a bunch of little pipes out.
Correct.
And then that goes to the leaching field and takes
all the liquids
and puts them back into the ground out here. Now, I don't know if you remember when we were talking about foundations, we talked about why there was such a high foundation wall on this side. And the explanation that I gave you then, which is still true today, the ground that I'm standing on is probably about 5 or 6 feet above the natural grade. The water table was about 2 feet below that grade. So if we dug down about 8 feet here, we would basically be standing in water in that trench. So we have to bring the septic system up, because when we drop those liquids into the leaching field, they need to be able to percolate into the ground. And if the ground is already 100% charged, we don't get that percolation, right? So we had to build this system up, pull the house out of the ground, which actually helped us on the walkout on the other side. But that's why we're on this kind of elevated septic system, septic field here, because of that very, very shallow water table here. So I'll tell you, Wayne, it was a great day. We got to talk plumbing. And I know, you come here every day, you work very hard, you lay it all out, get the job done, and then you're on to the next job. But it's, beautiful work in there. You got any parting words for us?
Oh, thank you, Steve. Appreciate doing the walkthrough with you, and looking forward to doing a segment on the finish with you.
There you go. All right. Well, that's it. You heard it here from Wayne himself, Foston Plumbing and Heating. right, what's up, Brett?
What's going on?
How you doing, buddy?
Good.
Now, for those of you that might not remember, or if you haven't seen any of the previous episodes, Brett is part owner of Green Logic Builders, general contractor here.
Yep.
And you're not only the builder, you're the homeowner. You are the client
and the builder.
The client and the builder. So very unique setup. Not unique to me. I've done a lot of builders' houses. But one of the interesting things about this, we call it multi-gen, on a budget, but it's a small compact house. 2,000 square feet upstairs for you, your wife, and new baby.
Yes, sir.
And then downstairs, I believe your parents are down here. So 5 people living in the house, basically 2 units of living crammed into 2,900 square feet.
Yes.
Now, one of the important things about that is it doesn't eliminate all the stuff that has to go into the house.
Right.
We have a lot of stuff, mechanical system, dehumidification systems, fresh air systems, ventilation for the stoves, both of them. So there's a lot of things that happen here. And, we talked earlier when we were doing the floor framing about using open web trusses, but before we even got to the framing, we had a discussion with our friends at Energy Vanguard.
Absolutely.
Now, this is an engineering firm. They're down in Georgia. They're headed up by a friend of mine, Allison Bales. A great engineer that really has just a really firm understanding, and the people that work for him, about residential construction and engineering practices. I know some of you might sit there and say, well, we'll get it. My brother-in-law is a mechanical engineer. Yeah, but if he's doing hospitals, it's a different animal.
Completely different.
Right? Different systems, different animal, different air tightness specs, window specs. There's a lot of things that are, I would say, kind of a little more micro in this system because it's not 500,000 square feet of space. So we worked with them. We don't have to dive into the details, but they did do a full layout for us.
They do. Yep. Size of the equipment, the ductwork, help specify the equipment, pretty much give you enough and rules on where you can modify and can't modify, because everybody knows in the real world of construction, unless you are going to the nth degree and having everything overlaid on overlaid on overlaid, you have to make some adjustments.
There's some decisions.
And they give you the rules on how to make those decisions correctly.
Yeah, and decisions are about getting the best value for my dollar.
Yep.
And we talk about it being on a budget. Now, we're in the Boston area. Obviously, the budget that I have here is different than, say, the budget with Jake Bruton in Missouri.
Sure.
Right, and that's because plumbers cost more up here. Electricians charge more up here. Mechanical guys charge more. So it's still on a budget. It's just at an elevated scale from some other places. Likewise, if I go to downtown Boston, I'm probably paying all of those trades 150% of what you're paying for them in the metro area.
Yep.
Right. So starts with a good plan. We have the plan, and we should take a walk through the house and talk about all the pieces. Now, we're downstairs in your parents' unit. One of the things here was we had a clash with structural and mechanicals.
Correct.
Right? We did the open web trusses. We said, we could just run this through. And then after our structural analysis, we realized we need to have a steel beam in there to put a moment frame in.
Yep.
And in this case here, we probably didn't want to drop it down, even though we had the headroom. We don't want this gypsum board encased steel beam running through the middle of our kitchen.
No, it wouldn't work as well in this space. This is their main living space. This is where they're going to spend all their time, and it's a different scenario than what we have one floor up.
Yeah, so we have that beam. So we have a bunch of systems on that side. We have some systems on this side. And then in the pantry utility closet there, we have a few ducts that jump underneath the beam, kind of a dirty closet, if you will, to make that happen. And granted, this is probably, I would say, about 50% of their space. But because of the efficiency, the windows we're using, the calculations, I only see 3 supply ducts for this space. So, when you're building with the right decisions, that helps to minimize the amount of energy we have to use to heat and cool this space.
Absolutely.
Right? So, obviously we have the beam there. We had a bunch of these ducts, if you remember, we had them dropped in at the framing stage so they could slide in as one piece. But I heard you, you know, when we were talking upstairs, there's still some knuckle busting going on here.
Of course, there is. I mean, you have your strong bags for your truss system. We have plumbing when we're in our wet areas. I mean, it's tight. Like, it's open web trusses allow you the ability to do this, but it requires work. And our guys have done an excellent job. They're not cutting corners.
And if you've seen some of my other videos, you know, I go down and I talk about the dirty basement and there's just stuff hanging all under the trusses.
Right.
Understand, in this case, that 14-inch floor truss system, that's our basement.
Yep.
For the most part, right? Everything is running in that truss plenum.
Everything.
That is basically servicing the downstairs unit. So my understanding is the planning, this floor here has its own heating and cooling system. The 2 floors above are on their own system, which makes sense. 2 different units, 2 different systems.
Yep.
But in addition to the HVAC, the heating and cooling, we have some elements like this blue tape here. This is the extraction for our range hood.
Correct.
Right?
Yep.
And I can see this goes to what looks like some kind of muffler type system.
Similar, silencer.
It's a silencer, so you don't get that fan noise and everything going through there. And then just beyond that, we have an inline fan.
Correct. From Fantech.
And that basically vents to the outside. So this will all be synchronized to the switching on the range hood.
Exactly.
You turn the fan on, inline fan comes on, sucks this through, silencer, keeps it nice and quiet. Everybody's happy, and we get the extraction that we need. Now, one of the interesting things about this house is it's all electric.
Yep.
Induction cooktop, I'm assuming.
Yes, sir.
Right? So we don't really have to worry about bad things in the house. It's mostly odor control.
Yep.
Is the whole purpose for putting that in.
Yep.
Cooking fish or something bad, you want to turn the fan on, evacuate that air, bang, we have it. Now, just on the other side of the closet here, I notice in here, we have 4, they look like around 5-inch pipes.
Yep, 5-inch round, you got it.
So, and they're labeled IE.
Intake and exhaust.
So those 2 communicate directly with the outside.
Yep.
Right, so one is bringing outside air in, one is exhausting inside air out, and then up here, supply and return, obviously one is supplying outside air to the basement unit,
Filtered.
filtered basement air,
And partially tempered as
And
it
partially
passes
tempered.
through the core.
and then we have the return air that goes through the system, ERV,
Yep.
so we're stripping the energy off of that
Yep.
and dumping it to the outside.
Exactly.
And again, because we're in kind of a confined system here in this 900 square foot unit, all of this is happening in the head of the closet,
Yep.
right? So it's a pretty shallow unit. It'll be above the doors,
Yep.
and all of that stuff will be happening. And you'll be able to exchange the filters
Exactly.
and everything nice and easy.
And why is it here as opposed to in our mechanical space? Because, as I mentioned, there is some knuckle busting work to get all of this to fit into the small space, and it all converges in our mechanical room. So to have a couple less runs of ductwork going into there and figuring out where can I poke out to outside, it made a lot more sense to put it here and not funnel into that bottleneck over there.
Gotcha. And as we go through here, on our way to the mechanical room, I notice some of these are round, and I'm assuming that is for the ERV.
Yep.
Ventilation system. And then the square stuff, this is for our supply duct
Yep,
system.
exactly.
And I'm assuming this probably has a central return system for this
No,
floor?
we have supply and returns in each room. So
Okay.
that is a supply, that's a return in that
The
corner.
return on that side. there.
And then for the main living space, we have our,
We have a large return there. So we have basically 2 returns that are taking that back.
and then I guess one other thing of note would be our bathroom, we don't have one-way exhaust. We pull the exhaust from the ERV, so we're maintaining a balanced home from a pressure perspective. So
Gotcha.
we install boost switches on all of our bathrooms. So you walk in, if you're gonna use the bathroom, hit the boost timer and your ERV ups the CFM. So we're
Basically
able to-
ramps up for a short time.
Yep.
That's pre-designated, Then after you shower, the good thing is it keeps running.
Keeps running. Just
So
out
it
of-
evacuates, and then at a certain time it shuts down and comes back down to normal speed.
Yep, exactly.
All right, so as we make our way to the mechanical room, I notice, you know, another duct there, another duct here. One of the things, before we talk about exactly what they are, I want to commend you. I haven't seen one open duct in the house. Everything is closed off, taped off, sealed. Professional job done. For you younger builders out there, or for your older builders that are saying, hey, why don't I have, you know, great clients? Why are my clients always complaining? Well, maybe you should think about what kind of services you're providing. What does your job site look like when you're walking around with the client? Now, in this case, you're the client. So on a couple other videos, I said everything's damn near perfection.
I wish that was true, but I appreciate that.
But you're here every day. So let's talk a little bit. We have this one over here.
Yeah, so return air pathways, as we mentioned, we have a dedicated return in this bedroom. So this is our closet here, just helping the airflow there.
Gotcha.
And then this is actually a supply for our dehumidifier that we have here in our mechanical space.
Okay, so let's head on in here and let's talk a little bit about what is happening. Now I know I had the plumber in here, I had the mechanical or electrician in here, panels, plumbing, ejector pumps. One of the beauties of having a higher ceiling here is mechanical systems we can put in the air.
Yep, so supply for the dehumidifier. This is actually going to go and connect to the supply of our air handler, which is going to live in the ceiling over here. All of our mechanical equipment is basically going to be from this height and up, so we can get through our mechanical space, service everything we need to, be able to change filters, and this tight space will function.
Will function everything. Now, it's interesting that transfer grill, it's a two-way transfer grill because it's sending air to the return that way, but when this dehumidifier kicks on, it's sucking air out of that room and putting it into the system and then redistributing it through the supply duct of the main system. All right. Well, let's jump upstairs and see what kind of systems we got up there, because it's just a whole different set of situations up there. So let's head on up.
Let's do it.
So I notice, you know, Brett, as soon as we come up here, you know, unlike downstairs, we talked about that moment frame and how it basically cut our system into two sides, east and west, right?
Yep.
Here, we had the luxury to be able to drop that architecturally. It works as a room divider.
Yep.
So we have our kitchen and dining room space. We have our family room space there. But the beauty is now stuff can go over it.
We have a lot more ductwork in this floor system because we're servicing 2 floors, whereas downstairs it was just that single floor. So in order to get under this beam in this scenario, we would have had soffits. It would have been a nightmare,
It
really.
would have been a nightmare, yeah. No, I agree. And, you know, to understand that, downstairs, we're just servicing 1 floor, so it's basically a blow-down system.
Yep.
Here, we're coming through and it's a blow-up and blow-down system, like you said. So basically, or theoretically, twice the amount of ductwork in this floor than down the floor. And it's just not only ductwork. We have our standard supplies and returns, but we also have, you know, the same stuff we had downstairs. We have our extraction for odor control at the stove. And I noticed that goes in and we have the same silencer, same inline fan. And we use the function of this being a pantry that we have a really short distance from the range to get that outside there. Now, one of the things that we don't have up here, because we have a unit below us, is we don't have the luxury of a basement.
Right.
So we have to be somewhat unique in understanding, where does the air handler go? Where does the ERV go in this one? And I know we have some pretty cool solutions here.
We do. Yep, we have a lot going on in this closet here. We're fitting a whole house worth of mechanical equipment, and not just any house, like a house that cares very much about their air quality, into one closet. So we have our air handler that's going to service 2 floors, is going to live here. We have an ERV and dehumidifier are going to live there. We also have our filtration for the makeup air for our range hood, the Fantech system that we were talking about. So we are fitting a lot into a small space, but it all fits.
And for those of you, you know, putting the HVAC system in here or the air handler, well, we have to make sure that we have locations for the return duct.
Yep.
We have to have access to the supply ducts. We have to have a condensate drain.
Correct.
To get rid of that. So it's not, hey, let's just put a big box in here, plug it in, and we're good.
Yep.
That big box has a bunch of things that it has to connect to
Yep.
to service the house here. And I noticed we have all those threaded rods. So just like downstairs, we're going to do some air time with our dehumidifier and our ERV up here.
Yep, exactly. I mean, it is a bit of a puzzle making everything fit. I mean, it's a large closet, but like you said, it's not just the boxes, it's also the ductwork to connect everything. So it's
making sure. And it doesn't help that, you know, the architect narrowed the house down here.
I like the architect a lot. Don't
It
talk bad
kind
about
of
it,
funneled
right?
everything down here, but you guys did a really, really good job. Hats off to Energy Vanguard because they did a really good job of, you know, putting all of this in here. And, you know, the beauty of your decision to make a lot of right decisions, outsulation, air tightness, good windows, that means all of these systems can decrease in size.
Right.
And, you know, Energy Vanguard, they have the experience to understand how small can we make that.
Yep, exactly.
Right. So this house is one that there's not 150 or 200% of heating and cooling built into this.
Right.
This is a fine-tuned, good running machine
Yep.
that isn't going to be on and then shut off for 15 minutes and then run. This is going to be a nice, steady use
Exactly.
on this. So why don't we jump upstairs? We'll finish the tour. We'll talk about what happens in bedrooms, return strategy. I know we got some fun stuff happening up there, so let's
do it.
take a look at that. All right, Brett. So we're on the top of 3 floors. This one's being supplied from below us, but the strategy here is a little different. This one here, we went with a central return strategy. Right. So what that means is we have one return services the whole floor, which makes it very economical, very convenient.
Yep.
But now the issue is if I supply to these bedrooms, I need to be able to equalize the pressure that they come under with that supply.
Correct.
Now, here we have our transfer grill. Tell us a little bit.
So it's all based on the load for each bedroom. So this bedroom has 2 exterior walls, 2 windows. The load in this bedroom is going to be more than, say, the load in this bedroom. So for this one, we need more than just the undercut of the door. We needed to provide more open pathway to get back to the return.
Right.
So
So when that kicks on, it's basically sucking from the hallway. The
Yep.
hallway in turn sucks from the bedroom. And when Brett is talking about loads, just to be crystal clear for those of you maybe not familiar with construction, he's talking about heating load. We're in climate zone 5, so there's times of the year it's really cold outside. And we have to pay for the heat inside here, and that heat is trying to leave. Well, that bedroom has probably a little more than 2 times the surface area than this bedroom relative to the outside.
correct.
And so, hence, has twice the load that this room has.
So we need more of a pathway to equalize the pressure in there. Here, this bedroom, the undercut on the door will be enough to get air back to our return. That bedroom in the front of the house has a larger load. It's also, we have the bathroom back there too, so we needed the return air pathway for that.
Yeah, and that, I mean, that owner suite, it is pretty much about 40%
Right.
of this floor itself.
Yep.
Right, so hence the need for the transfer grill. Now, as we move down through the hall here, I know this is the laundry room. We talked about a number of things with the plumber in here, but one of the interesting things is I don't see a vent for the dryer.
No, we have a ventless dryer, a heat pump. So once again, going back to our strategy of not having any exit-only exhaust, keeping a balanced house, the heat pump dryer lends itself very well to that.
Right, so no vent, we'll condense the water in here, drain it, take care of it. And then I notice we have some ducts here, but these aren't heating or cooling ducts.
Correct, these are for the ERV. So we exhaust from the dirty rooms, bathroom, kitchen, laundry room in this instance.
Yep.
So just like the bathrooms, we'll mount a boost timer to the wall when you come in here. So if we're doing drying a load of laundry, we can hit the boost timer. So we're extracting a larger volume of air while the machine is running.
Right, and then we have obviously the supply to one of the walk-in closets here. Now, I noticed that we don't have a heating duct in there, which is fine. It's not a very big room, but it's really important if I don't have that heating duct to have this supply, because that's going to move the air around that room.
Correct.
So that when that closet door is closed for a week or few days, you're not getting static air in there.
Right.
Right, that it's working. Now, you know, beautiful job. One of the cleanest job sites I ever visit. It's always a treat coming here, real easy to shoot the video. One of the things I've noticed is that you use the zip tape over one of the, or over the registers.
Yep,
We'll see if we
that's a
can't
little bit there.
find one here. Yeah, so, you know, one of the things I noticed is another great use of zip tape. I noticed all of the ducts, which I can't tell you how many times I go in a job site and I know it's a central return and I see gypsum board scraps, I see plaster in there, I see sawdust in there. Yeah, they're gonna vacuum it out, but how much of that went down the pipe?
Yeah, you're never going to get all of it. And I mean, this equipment isn't cheap and we want it to last for a long time. So why would you commission equipment that is already set up to fail by injecting construction debris?
Yeah, I mean, my perspective on it is clients are buying a brand new house.
Yep.
They're not buying a used product.
Right.
And when the builder doesn't care, it kind of seems like, it's like just a little sawdust, Steve. That's not the point.
Yep.
The homeowner, imagine if you went, Mr. Carpenter or plumber, whoever, and you went and bought a brand new truck and there was a bunch of sawdust thrown on the floor as you're picking your truck up. You'd be like, why isn't this vacuum clean? I bought a brand new truck, not this one with all this mud and sawdust.
Right.
So, you know, I commend you guys. Very clean job site. Always a treat to come here. Check it out. A lot of really cool things happening in this small house. I know if I were you, I'd be chomping at the bit. Let's finish this, let's finish it, because I want to live in it.
We are incredibly excited. I'm also enjoying the ride because not everybody gets the opportunity to build their dream home for their family. So.
All right, so we're back at the multi-gen. You can see we're a little further along in construction. We got all the windows in. It's starting to get really exciting. But to enhance that excitement, we have Victoria. Victoria is the product manager of heat pump water heaters out at Bosch. I call her Miss Water Heater out of respect, because if we need questions answered about heat pump water heaters, we turn to Victoria. So tell us a little bit about the history of Bosch heat pump water heaters and why this recent emergence of the heat pump water heater.
So heat pump water heaters are for sure the most efficient water heater systems when it comes to electric water heaters. And we have been in this market like 10 years ago, but people weren't really ready for the technology. Right. And we also saw there's a lot of upfront investment for a heat pump water heater because you have the heat pump module inside. But now we're finally seeing that the government puts a lot of efforts and incentives behind the heat pump water heaters. So we'll see that as a great move, and it's now the time for us to come back into this market with a great product.
And that varies, I think, across the country, but I know here in Massachusetts, you can get rebates upwards of like $2,000, $2,500 for just installing the heat pump water heater.
Yeah, so there's, for instance, in Massachusetts, we have Mass Safe, which gives you $750 off the product already. And then you have federal tax credits, the 25C, where you can get up to 30% back for the whole installation.
Gotcha, gotcha. Now, heat pump water heaters, there's certain requirements that come along. There's a certain amount of square footage because they're taking their heat from the air, the ambient air of the house, and they're putting it into the hot water. And as a result, they're cooling some spaces, right? And that's how they get their heat. So you need a certain amount of cubic footage of air, I'm assuming, that needs to be able to put that heat into the water, right?
Yes.
And what are those metrics that would be
So
looking
we're
at?
saying 700 cubic feet in an enclosed room.
Okay.
So you have different options. So we have also duct adapters, which you can use. So you could exhaust or intake the air. You can work with louvered doors. So there are many options to get the airflow you need.
Right. And I'm assuming, I mean, the earlier generation, they've certainly gotten a lot better. I'm assuming, I haven't seen one of yours yet, but I'm excited to see it get installed. But the earlier versions, I know we've put them in like closets on the second floor. They were a little noisy, but they've gotten a lot better.
Yeah, we're
Right.
like around 49 dB.
Okay.
So it's like a refrigerant, basically.
Okay, so you don't really hear it. The concern of we're going to put it in there and we're going to hear this thing humming through the night when I'm trying to sleep, those things aren't really an issue, right?
No.
What do you say we head downstairs? We'll go right into the space we're going to put it, and we can continue this talk, and we'll talk a little bit about those metrics.
Yeah, sounds great.
All right, let's head on down. All right, so we're downstairs. Now, because this is an ADU, accessory dwelling unit, right, multi-gen, this is basically an attached apartment on the first floor. And one of the things that struggle with as an architect is space, right? Everybody wants a bigger living room. Nobody wants to give up space for a water heater or an air handler or mechanical equipment, but we have to. And so, Victoria, you said you did the calculation. We're probably at something like
600
cubic feet. So we're almost at a successful cubic footage to not necessarily connect with the outside, but it's probably still a good idea.
Yes. So we could basically use the cold air and the dehumidified air to actually dump into the living space. That would help the cooling load, right?
Yes. And the humidity load, right?
Yes,
Because you're
exactly.
going to dump drier air out there. And so our options are, this comes with a dedicated exhaust port if we
Yes.
wanted to use it. So
Yeah.
we can simply just duct that out through one of the walls and go out through, you know, we had this little mock-up here where we could get this somewhere in the wall. We'll plug into it. We're going to come back. We'll have Victoria back and we'll talk about exactly the option of choice. But we could also do a louvered door.
Yeah, we could do that to
Right,
get the intake
on the
and the
pantry.
exhaust. Exactly.
And then use the space and connect it with that. Or again, we can look at that ducted option there. Now, the water heater, this is an 80 gallon that we're using here for basically the 2 units.
Yes.
Now, you guys have other sizes.
Yes, we also have a 50 gallon. So
Okay.
that would be for a single family house, so one family. But we're also bringing out a 65, which is like kind of in the middle.
In the middle.
Yeah.
So for those where I don't quite need 80, but 50 isn't quite enough. And honestly, we've done a number of projects, especially some of our larger ranch, when we're doing 4,000 square feet, I'll actually put in 250s
Yeah.
and put them on separate sides of the house, just because the plumbing between, say, a sink on this side and the water heater, we might be over 100 feet.
Yeah.
And
And
that's
you
just
also
not-
want to size really up for a heat pump water heater, so you have the most efficiency. Like you
Right.
can use all the heat from the air you have and dump it in and have it ready for when you want to use it.
Right. Anything else special about the water heater that you want to talk about?
I think what is also great, I mean, we're in a new build here,
Right.
but I know it's like a traditional electric storage when it comes to connections. So we have the 30 amp, 240 volt breaker, which is the same as a normal electric storage. We have the same water connection, 3/4 NPT. So there's really nothing new
Right.
in general.
And that makes really good for retrofit situations where if you go into a house and they have an existing electric water heater and they want to upgrade to the efficiency.
Yeah.
Can you talk a little bit about, like, what kind of efficiency do we see when we move from, say, the standard electric water heater to the heat pump?
We say 3 to 4 times more efficient.
Right. So right there, and with all the rebates, it's a question of why am I not replacing
Exactly.
those water heaters at this
Yeah.
point, right?
And we see even the Department of Energy just released 2029, everything above 35 gallon must be a heat pump water heater at that time.
Gotcha.
So we're not compromising any comfort. So we have the electric resistance heating elements inside. So if you really have problems with the heat pump catching up, you have a high demand, you have maybe 3 guests over and you want to take 5 showers in a row, you can always make use of the electric heating elements.
Gotcha.
So you don't have to wait for the heat pump to like really heat up the whole tank.
Understood. Now, I know we're very fortunate in New England because Bosch has a showroom right here in Boston.
Yes.
So if you're a builder, an architect, or a homeowner, and you want to go see this Bosch equipment, heating, cooling, heat pump water heaters, you can go right into Boston and see these at your design center, right?
Yes, and meet me there and I can talk about it.
Okay. Are there any other places across the country, or is New England special?
Yeah, we have our office in Watertown, so that's the way. But we also have a training center in New Hampshire.
Okay.
So where we train contractors.
So they can come up and learn everything there is to learn about your
Exactly.
products and such, and installation. Well, thank you very much for joining us here. We'll definitely have you come back. We're going to get these water heaters in. We're going to get our heat pumps in and get this place rocking and rolling. And we'd love to have you come back and talk a little further about it.
Thanks for having me today.
All right.
Thanks, Steve.
Well, there you have it. Heat pump water heaters from Miss Water Heater. All right. So we're on the outside of the house. We're going to catch up with Mohammed. Mohammed's one of the senior product managers out at Bosch. And we're going to talk about IDS systems.
Yep.
How you doing, Mohammed? Glad to have you out here at the job.
Thank you. Appreciate
it. So IDS systems. Talk to me. What does IDS stand for?
All right. So IDS is inverter ducted system.
Okay.
Is our portfolio of inverter ducted heat pumps. And it is our mission to advance heat pump technology within that portfolio.
Okay.
So within that portfolio, the IDS, we have our IDS Lite, IDS Plus, Premium, and now we're coming up with the IDS Ultra, which is our cold climate heat pump.
Being an architect that works in other climate zones, that connected series, which is kind of a step up. Tell me a little bit about that.
Yeah, so for those other climate zones, we'll have the IDS Premium connected, right? So IDS Premium connected, even in Massachusetts, have been doing very well. What's special about it is connectivity, right? This was the first heat pump that we added connectivity to it. The Ultra will have it as well. The IDS Premium connected comes with a gateway, a 4G gateway, as well as Bluetooth. Okay. So with the 4G, it's able to communicate faults with the installer or with the contractor. It's able to show energy usage to the homeowner. And the
is that I don't mean to interrupt. Is that the connectivity? I'm trying to understand what the link to, you know, I love buzzwords, but when people throw buzzwords, they got to mean something to me.
Yep.
Right. So when you're talking connectivity, that means the HVAC tech can analyze the system from a distance?
Exactly. So what we want is for the HVAC tech to know what's going on with the unit before they make the trip. So they make sure they have the right equipment in place in their van and not to do multiple trips, right? So they're able to see the fault. They're able to see, you know, how they can troubleshoot it, right?
Right.
The homeowner is able to see the energy usage, and they'll get notifications as well if there are any faults occurring. And with the easiness of this, they'll be able to call their contractor and make sure that the equipment gets addressed.
Right. So they get the alarm, the HVAC tech gets a kind of a pre-analysis of the problem that they can then diagnose and come out here with the right parts. And
exactly.
It basically saves a lot of time, aggravation, and makes angry people happy real quick.
Yep, exactly.
Right.
And in addition to that, during installation, the contractor can come in and via the app, connect to the equipment and see live data. So they're able to see the sensor values, they're able to see if there are any faults. It can also help them with charging, and that's done through Bluetooth with the same gateway.
And so they can fully understand when they walk away, they can walk away in confidence knowing this system is working at optimum performance or what it was designed to do.
Yes, exactly.
Well, that's the direction we're going in a lot of things. It's great that Bosch has taken that, leap forward in helping us in the building industry to not only solve problems when we're hooking this up, but to help diagnose problems down the road when something isn't performing like it should.
You got it. Thank you.
All right. Well, there you have it. The utilities, electrical, plumbing, mechanical, we hit them all. You know, the team here is doing an amazing job. It starts with Brett, his oversight, working really closely with the electrician, the plumber, and the mechanical guy, each of those trades working with their individual teams to get everything right. We have a lot of stuff in this house. It's crammed into some very, very small spaces, but they did one hell of a job putting it all together. Have no fear, it doesn't end here. We have insulation, we got drywall, we got windows, siding. We got a lot of exciting stuff coming up. I'm looking forward to more of this build. Stick with us, look to the future, catch us on these upcoming episodes. Until next time, I'm Steve Basic Architect. This is The Build Show, and this is our multi-gen project on a budget. Until next time. All right, so shooting. We can't bring you these videos unless we get partners in the industry to team up with us to ensure that we can bring you the best content possible. Today, I'd like to throw out a huge thank you to New Wool Corporation. If you're not familiar with them, 75 years in the business. Now, one of their stories that I think is probably the one that's priceless is 86% of their product is recycled content. Very, very little virgin content going into their products. So they're taking waste products and finding a way to bring it to you to use it in a useful, carbon neutral, carbon plus manner in your houses. And one of the interesting things that I just learned is that their manufacturing process is 1/10 of the energy that it takes some of their closest competitors to create their insulating product. So not only are they highly recycling it, but they found ways to be very innovative in their manufacturing process. And that means they're bringing you a really good quality product. Let's talk a little bit about their products. You might know them, they're most famous for their loose fill insulation. Yeah, it's cellulose. It's recycled paper, cardboard, it's treated with borates, so it can handle the fire, it can handle the sound. You saw that we're using it in acoustic situations as well as really good thermal situations as part of our thermal barrier. And not only do they give you the blown-in cellulose, we can use this as loose fill in the attic like we did here. We can add a little bit of moisture at the nozzle, put it in the wall as a damp spray cellulose, or we can net and blow this stuff in and get a dense pack situation, all of which yield right around that 3.8 per inch. If you want to move to a bat situation, then they make these EcoCell products. They make it in a 5.5 inch bat, they make it in a 3.5 inch bat, R13 and R20 respectively. Now the beauty of this, I'm sweaty, it's hot, I've been out here all day. I'm not gonna sit here and be full of irritants, right? It's healthy, you can put it in your house, you can put it in the baby's room, and we can ensure that the family lives happily ever after. If you're looking for special situations, they have their EcoSeal blanket, comes in 1.5 inches and 2.5 inches. This is really good. You know my detail where I do the foundation wall and we hold off the framing that 1.5 or 2 inches? Well, here's your solution. You can put this in, it's hydrophobic, it's pretty much all natural, nothing in here that's gonna harm the family. You can put it in, it can wick the water, drain the water, dry it out. It is a great solution if you're looking for those alternatives to using other insulation products. So probably one of the things that you didn't know, I didn't know it, was that there is a 10-year guarantee by New Wool, an energy guarantee. When the project is done, this project specifically, they are going to give a not to exceed price, and if the energy bill exceeds that price, New Wool will pick up the difference in their guarantee. Not many insulation companies are willing to put their mark on what they say. Great thanks to New Wool. Not only did they team up with us, they sent their whole team out here. You saw it in the video. I had Heath out here explaining everything. We went up to the factory. We saw how this stuff gets made. We talked to all the important people there on what they're doing to bring you the best product they can bring you.